So welcome to this third video where I'm going to show you how to use Python Go to run an extended programming project with your students. And you might be wondering, as Python Go is not a cloud-based solution, how it's possible for a student to tackle a complex project such as this over time. And the way I've done it with my groups is to create a little version control document such as this. It teaches them some really good habits actually. And I provide them with this link to version 1.0 of the project. And the idea in this actual project is students make a little 2D drawing of a house. And there's always one or two students that take this well beyond the project spec. As you can see, this three-dimensional drawing here is absolutely unbelievable in terms of the quality of the work. It must have taken 20 hours. And it's meant to be more like a 3 or 4 hour project. But the idea is students get a project brief on the VLE page. I give them a little starter code such as this, and then they get programming. And at the end of the first lesson, they can save their progress. So let's assume I'm a student. I've loaded in using this link, and you'll notice it's coming actually, if I just cancel this, it's coming as shared.py, and the students could run this, but if they actually want to edit it, it asks them if they'd like to overwrite any work they've been doing previously. These students just got this basic stuff here, so we can overwrite that, and we're now into mycode.py, and I'll do a little basic house. I'm going to keep it super simple. I'll create a turtle. I like to call mine Bob, and then I'll do for iron range, let's just do a square, bob.forward 100 and bob.left 90. And I like to teach my students to do turtle.done, and I know that's not relevant on a browser-based programming solution such as Python Go, but it's good habits to get into, particularly if you're going to be programming locally in Turtle at any point. So if we run that, we've got our house in quotes. I'm well aware it's pretty basic, but let's imagine that that's the end of the first lesson and students have wanting to save their work. So first of all, version control, we're going to do version 1.1 up here, and I want my students to press share. And we can call it version 1.1, and the student doesn't really need to put their name on this because it's in a Google Doc with their name on it, so we know who it belongs to. I'm going to press copy, pop back in to our Google Doc, and the student can put their link there. And they could say, drawn the front wall. This is them recording what they've done. Let's say the next thing I'm going to do is the door and the windows, etc. So that's a little log of what's next. You could say you're in the classroom, and let's also say that we were, I'm just going to make this up, the 16th of March 26. So let's say that's when this was happening. So that's one way that a student could record their progress. So they may then close down Python Go. So let's say it's the end of the lesson and they've closed that down. And then they could come back next time and continue where they were. Now, if they did come back next time, it should still be in mycode.py because if they've not done any more work, it's just there. So if they were to launch the site, it will be there because this is stored inside local the browser local storage. But if for whatever reason they'd be doing some other programming, maybe with another teacher or something, they could click this link, and again it will pop back up into the site as shared.py. And when the student tries to add to it, like this, it'll say, are you sure you're going to overwrite this thing that you've got there? Now it happens to be that the thing they've got there is the same as the same thing, so it makes no difference, but it could be something different. And then they're into working on version 1.2, and maybe they're going to add some windows and other features. So that's the basic premise of how you would work on an extended project over time and save different versions of it. And imagine if this was my finished product. I'll just put hashtag I am finished. I can't imagine the students scoring very highly with this project, but they could go into here and say, this is my version 1.2 and I just can't do any more. I'm done. And we could pop back into here and paste that there. And so that's how students could access previous versions and store a history of what they're doing over time. Now, if I take that onto this other page here, which is the finished product for a student that I've mocked up here, you can see the student really did go for it. In their first lesson, they've done a roof and a chimney and so on. In the second lesson, they've added windows. And in the third lesson, they've even added a sky and clouds and I believe a sun. There's a sun in there as well. So this is what it would look like for this student. They could click on here and it loads in whatever they did at the end of the first lesson. You can see they did have the beginning of a house. And then you can see what they did at home. and press run on that one, and that's now got Windows. And then we can go back again and have a look at their finished product. And this is a really good way to see students haven't just used AI to cheat, because you can see the house developing over time. And if a student was to copy work off someone else, it'd be pretty obvious there'd be no version history. So I actually think this is working quite nicely as a system with my students. And yes, it isn't a cloud solution, and Python Go was never designed with that in mind. It's actually running locally in the browser, and the actual URLs down this side store the code. So if I was to click on that one there, for example, that the code for the student is encoded inside that block of text. So the code is stored locally inside this document instead of being stored on the Python Go server. So that's it. That's how you do an extended project with your students. And if you haven't tried it, this house drawing project really is a bit of fun. This student here had different seasons. You could select autumn or spring, in this case winter. Obviously this student's gone absolutely overboard with bricks and so on in a three-dimensional drawing. And we give away little prizes to our students, little vouchers, Xbox and PlayStation vouchers for winning entries, and we make it a competition. So I think there's a couple of good ideas there. One, how you could use this version control document, and maybe two, run a little competition like that with your students and see if they engage with it. So that's it. That's how Python Go can be used on an extended project, and I hope you find that useful.